So this is Aksha of Computer Science and Engineering from first year. Today my topic for presentation is semiconductors and intrinsic semiconductors. Moving on to next slide. Introduction to semiconductors. Semiconductors are materials with electrical conductivity between conductors and insulator. They are crucial in modern electronics, enabling the functions of devices like transistors and diodes. Understanding intrinsic semiconductor is essential for grasping the fundamentals of semiconductor physics. Moving on to next slide. What are intrinsic semiconductors? Intrinsic semiconductors are pure semiconductor materials without any significant dopant atoms. Silicon and germanium are the most examples of intrinsic semiconductors. Intrinsic semiconductors exhibit unique electronic properties due to their atomic structure and bonding. Moving on to next slide. Atomic structure of intrinsic semiconductor. The atomic structure of intrinsic semiconductor consists of lattice of covalent bonded atoms. In silicon, each atom forms four covalent bonds with neighboring silicon atoms. This bonding structure contributes to the material's ability to conduct electricity under certain conditions. In this picture, we can observe example of intrinsic semiconductor. Moving on to next slide. Band theory and energy bands of intrinsic semiconductors. Band theory describes the energy levels of electrons in solids divided into valency and conduction bands. In intrinsic semiconductors, the energy gap between the valency band and conduction band is relatively small. Electrons can be excited from the valency band to the conduction band, allowing for electrical conduction. Here we can observe the energy band theory and distribution of electrons in shells and subcells of intrinsic semiconductor. Moving on to next slide. Electrical conductivity. The electrical conductivity of intrinsic semiconductor is temperature dependent. At higher temperature, more electrons gain energy to cross the band gap, increasing conductivity. The intrinsic behavior is in contrast to extrinsic semiconductor, which have added impurities to enhance conductivity. Moving on to next slide, temperature effects on intrinsic semiconductors. As temperature increases, the number of charge carriers in intrinsic semiconductor also increases. Thermal excitation can promote electrons from the valency band to the conduction band. This results in greater electrical conductivity at elevated temperatures compared at low temperatures. Moving on to next slide. Applications of intrinsic semiconductors. Intrinsic semiconductors are used in various applications, including photodetectors and sensors. They serve as the base material for many semiconductor devices due to their unique properties. Understanding their behavior is crucial for designing efficient electronic components. We can in this picture, we can observe examples of semiconductors. Some examples of semiconductors are microcontroller, memory, display drivers, audio drivers, keyboard controllers, discrete transistors, and diodes. Moving on, SGP, DD-PAN, TSOP. Moving on, these are the examples of semiconductors. Moving on to next slide. Comparison with extrinsic semiconductors. Comparison of intrinsic semiconductors with extrinsic semiconductors. Extrinsic semiconductors are doped with impurities to enhance their electrical properties. Unlike intrinsic semiconductors, extrinsic types can achieve a higher level of conductivity. The comparison highlights the importance of doping in semiconductor technology and applications. Here we can observe extrinsic semiconductors. N-type, there are two types of extrinsic semiconductors, N-type and P-type semiconductors. Moving on to next slide. Future trends and research of intrinsic semiconductors. Ongoing research in semiconductor materials explores new intrinsic compounds for improved performance. The development of novel intrinsic semiconductors aim to meet the demands of advanced electronics. Innovations in this field can lead to more efficient devices and sustainable technology solutions. Conclusion for intrinsic semiconductors. Intrinsic semiconductors plays a fundamental role in the field of electronics and material science. Their unique properties make them essential for understanding and developing semiconductor technology. Continued exploration of intrinsic semiconductors will pave the way for future and advancements in electronics. Thank you.